Okay? Our main kind of tool that we're going to use to prove lines parallel, or the thing we're going to kind of take advantage of to show that lines are parallel, are, well, we're going to go back to like our angle relationships. Okay? So if you remember, we talked about corresponding angles, and we had the corresponding angles postulate, I believe, which said that if two parallel lines are cut by a transversal, then corresponding angles are congruent. Okay, so that's the original statement, right? If two lines cross by a transversal, or if there are two parallel lines crossed by a transversal, then their corresponding angles will be congruent. We're going to say now the converse is the version of the statement that flips that order around. Okay, so if we start with if corresponding angles are congruent, okay, then the two lines crossed by the transversal are parallel. Okay. That's corresponding angles converse. And we also have, along with that, we have the alternate interior. I want to put in parentheses exterior as well, because this is going to be true for both of these things, and rather than have you guys write the whole thing out twice, I'll just kind of try to be a little bit clever here with the way we name this. So you can call this the alternate interior converse or the alternate exterior angle converse, and I left out that word angle, but you get the idea, right? Okay. So again, if alternate interior, okay, or exterior angles, I'm just going to use some symbols here. So if alternate interior or exterior angles are congruent, then the two lines crossed by the transversal are parallel. Okay, so again, if alternate interior or exterior angles are congruent, then the two lines crossed by the transversal are parallel. Okay. And there's one more special angle pair relationship, and that is the same side or co-interior angles converse. Okay. And this one, we're not looking to see if they're congruent, we're looking to see if they are what? What's the relationship between same side interior angles when the two lines are parallel? It's not when they're not congruent. What are these ones? Yeah, supplementary. So the idea here, right, is if consecutive, or if same side interior. If same side or co-interior angles are supplementary, Then the two lines crossed by the transversal. Are parallel. Okay. So that's it. So that's how we can kind of use those now in kind of like the reverse order. So before, we were told the two lines crossed by the transversal were parallel, and then we had those relationships. But now, we're not told necessarily that these two lines are parallel, and instead we're going to determine. If we can find a pair of corresponding angles to be congruent, then we know the lines are parallel. Or if we can find a pair of alternate interior, alternate exterior angles to be congruent, then they're parallel. Or if we can find a pair of same side or co-interior angles supplementary, then they're parallel. Okay? So, we'll do some examples here. So we're going to determine whether lines A and B are parallel in each scenario. And then we'll also say justify. Okay. And by justify, I just mean, how do we know? How do we know that whether they're parallel or not? What are we going to be looking at? Okay. What kind of special angle pair is giving it away? That's kind of the idea. Okay. So let's see here. So let's try a first one. I'll draw two lines that look parallel, but they're not marked that way, so we shouldn't assume, especially since we're asked about whether they are parallel or not. Okay, so if it's in question, right, if we're questioning whether they're parallel or not, we should not assume they're parallel. And cross by transversal here. And so I'll give us some labels. I'll say that's 127 degrees right there, and this is 53 degrees right there. Okay. So, can we use any of our kind of statements there that we just talked about as this is written? Like, do we have enough? I mean, is this a special angle pair, the way these two angles are marked? Are these, for example, are these corresponding? Yeah, no, they're not corresponding. Are they alternate interior? Yeah, no, they're not even in between. They're exterior angles. Are these alternate exterior? Yeah, no, they're not. They're like same side exterior here, so that's not really helpful. Oh, I know. If this is 53 degrees, can I say that this angle is 53 degrees right here? Yeah. If we knew the lines were parallel, we could, right? We could say, but do we know these lines are parallel? No. So I cannot say 53 degrees is this must also be 53 degrees. I can't say that. But what about, for example, can I figure out what this angle is right here? It's got to be 53 as well, right? Why is that? They're vertical. And do vertical angles require these lines to be parallel? So it's okay for us to say that this is 53 degrees because these are vertical. Okay? And then let's see here. This angle and this angle, well, they're vertical as well, right? So that's got to be 127. And now, what special angle pair do we have here? Same side interior, co-interior, not corresponding, consecutive interior, same side interior, a bunch of different names for the same thing. Okay? And so how should these be related? They should what? They should add up to equal 180. So let's see here. So 53 degrees plus 127 degrees, does that equal 180 degrees? And yeah. Check. So then in our answer, we could say something like this. A is parallel to B because, and then what's our justification here? What could we say? A is parallel to B because what? Which one of these same side interior angles are supplementary? Same side interior or co-interior, whatever you want to say. Same side interior angles are supplementary. Okay, so that's kind of like your final answer there, right there. Okay. Now, did we have to use same side interior angles here? Could we have done this a different way? Is this the only way we could have done this one? Yep, Ken?
127 is supplementary to the angle below it.
Ah, right here, yeah.
53.
Right, so we could have also used the fact that like these two angles here, okay, are a linear pair or supplementary, either way. And so then, yeah, this would be 53 degrees, and then that 53 would match up with this 53, and so we could then say these two lines are parallel because, what would we say then?
They're
Corresponding angles are congruent. Exactly right. Corresponding angles are congruent. So that's another way to do it. So there's sometimes more than one way to do this. To do these, okay? So don't worry if you get a different kind of explanation than your neighbor does or something like that. That's possible. Absolutely. Okay. All right. Let's see here. Let's try this one. I'm gonna change up the direction of the arrows here. Okay. So 3x plus 15 there, 60 degrees there, and then 4x minus 20 degrees there. And again, we'll call this line A here and line B here. And again, same question. Can we determine whether A and B are parallel here? Or how should we even go about starting to kind of tackle this problem? What could we do? So yeah, Hunter, what do you say? So, okay, good idea. So let's think about this. Can I say, are we allowed to say here that 60 is equal to 3x plus 15? Is that okay? So what do we think? Can I set this equation? I mean, before, right, we could say that these two things are equal. But what do I have to know that these lines are parallel? So unfortunately, we can't say it. If somehow, if we figure these lines are parallel, then yes, we can say those two things are equal. So right now, I cannot set 3x plus 15 equal to 60. Can't do that. So what's another idea here? Let's go to John, yeah.
You can set 4x minus 20 equal to 60.
Okay, now why are we allowed to do that?
Because they're vertical.
Right, and vertical angles, they don't depend on being parallel or not. So we can set those equal regardless. Okay, so I'm assuming, John, since we set those two things equal, we probably want to solve for x here, right? And that was your idea. So let's see here. Okay, add 20 to both sides. So x is 20. Okay.
I can go make that thing so if you hear loud noise, go over.
Okay, gotcha. Okay. So great. So now, how should we use this x equals 20 then? We've got x equals 20. Does that mean now what should we do? Yeah, plug it back in, okay? So we can plug it in, and is it okay if I plug it in here? The answer is yes, it absolutely is. This x equals 20, that is the value of x in this problem. So wherever I see an x, that x is really 20, okay? So, for example, right here I can do 4 times 20 minus 20, Okay, so that's going to be 80 minus 20, so that's 60. We already knew it was kind of 60 degrees, right, because of the vertical angles. And then the other one, 3 times 20 plus 15, so that's going to be 60 plus 15, so 75. Okay, so 75 degrees here, 60 degrees here. So are these two lines parallel then? Do we have enough information to say? Are these two lines parallel? Are A and B parallel? So Elizabeth. Yeah, alternate, yeah. Right, so we can use alternate exterior. What else could we use here besides alternate exterior? Corresponding as well. Either one, either argument there, but that's correct, exactly right. So, and I guess I could put like A parallel to B and put a little slash through it. So A is not parallel to B because, and yeah, let's use Elizabeth's answer. I'm going to abbreviate though. So alternate exterior. So alt-ext angles are not congruent. Good job though. Are not. Whoops. Sometimes my brain does some deja vu. Okay, so there it is. Okay. So let me give you guys one to try. Actually, I'm going to give you two here to try. I'll give you two here to try. All right, so y'all try. Y'all. All right, so the same directions here for number 3. I'll just give you a different kind of like setup here. Bless you. Feel like yeah. Okay. There's that one. There's the first one, number 3. And then number 4, I'm going to give you slightly different directions for number 4. I want you to tell me which lines, if any, are parallel. Oh, fits. Okay, good. Okay, so which of these lines, if any, are parallel? It's a big hashtag. Ooh, okay. We see. Come around, kind of. So I'll come around here, kind of. See what we think. A and B, which one are you looking at? Okay, fair enough. Right, so, but that's just like the ones that are next to each other. Right, you gotta look at like the corresponding, or alternate interior, or alternate exterior. For A and B? Okay, so what about for C and D then? Very bright. So again, how do we determine whether lines are parallel? Or congruent corresponding angles, or congruent interior, Okay. Anyone still need more time? We're all good? Okay, cool. So, number 3. Let's see here. Oh, where'd my clipboard go? It's hidden. Okay, over here. Tanner. What do you say here? What'd you do? Number 3. How'd you do it? 120 equals 2x plus 70. Okay. Math stuff. X equals what? 25. Okay, right? Subtract 70 on both sides. Divide both sides by 2. X equals 25. And then what'd you do?
I did 120 equals 2x plus 80.
So 120 equals 2x plus 80. Okay. So 2 times 25 plus 8. So basically you're like trying to see, are these two things equal? So, because they should be equal, right? Because these are what? Alternate interior. So, yep. So 2 times 25 is 50. And then 50 plus 80 is 130. So your conclusion was? A is not parallel to B because, yes. And I'm just going to abbreviate because alt, int are not congruent.
Wow, you really abbreviated everything.
That's right, guys. This is the legacy of, you know, the internet and stuff like that. We just abbreviate everything down to nothing. Okay. All right. Number 4. Which lines, if any, are parallel? Okay. So, what do you say, John?
I said C
C
and D are parallel.
and D are parallel, but A and B are not parallel. Is that what you're saying? Okay. So, how did you determine that C and D were the parallel ones here?
Because they had equal, like the vertical angles were equal.
Okay. So, what do you mean by vertical? Like, so you like labeled this angle right here?
What?
So, like this angle and this angle would not be vertical.
No, I have 120
And the 60.
yeah.
Okay. So you're not. So those aren't vertical then. What's that?
Equal 180.
Ah, right. So those are co-interior, same side interior. They're supplementary. Exactly right. And so if we kind of consider this here, okay. So if we look at, for example, forget this line B. If we just consider line CD and then A is like the transversal here. So CD, A is like the transversal. Then we have supplementary co-interior angles. Or if we ignore line A and we treat B like the transversal and CD like our parallel lines, and again, co-interior angles are supplementary. So yeah, C is parallel to D, okay, because they're co-interior angles there, or same side interior, what am I going to say? Same side interior angles are supplementary. If we try to look at A and B, okay, 60 plus 122, right? 60 plus 122 is not 180, and 120 plus 58 is not 180. So A and B are not parallel to one another. So that one's kind of hard to see, but that's right though. Good job, John. Exactly right. Okay. All right, so we'll go with that, and then to do is look at two proofs here, and then we'll get started on the homework. So I'll give you the two proofs. Okay, everybody's favorite. The important thing, guys, is that we're going to have some fun with proofs. And I printed them out for you, so there's no necessary copy. We're just going to fill in some blanks. Okay. The key word there is we're going to have some fun with There will be one proof on your test on Monday, or Tuesday, I should say, so we want to make sure. What's that? For quizzing. It's just one. Okay, so yeah, it won't wreck your whole grade if you have trouble with it. All right, and certainly I feel like everyone in here is capable of doing some of the proof, right? Like no one in here is completely blank when it comes to these proofs. All right. In fact, everyone can at least get a point by knowing that the first step, generally, is the given information. Right. So let's tackle though. Let's kind of read through this here first to kind of get our bearings. Okay. So we're given that segment HE over here is, what does the symbol mean? Perpendicular to side WL. Okay, and then the measure of angle HEW, so HEW, that's this angle right here, is congruent to the measure of angle A. Now, it might not look that way, but we're just going to take it for granted that it is. Okay, sometimes these things are not drawn to scale or whatever, but since we're told that they're congruent, then they are congruent. And we want to prove then that the measure of angle A is going to be 90 degrees. Okay, well, we can kind of convince ourselves that that's got to be true, right? And we think about it here. HE is perpendicular to WL, which means what kind of angle does that create? Perpendicular angles are what kind of angles? 90 degrees, right? So if HE is perpendicular to WL, that means that's a 90 degree angle, that's a 90 degree angle. And then we're told that the measure of angle HEW is equal to the measure of angle A. Well, what do we know the measure of angle HEW is? It's got to be 90, so what does that mean measure of angle A has to be? 90 degrees. And so really this is going to be an easy proof, right? It's got to be pretty straightforward. There's not that many steps, okay? So let's see how we go through this. So yeah, the first step here is segment HE is perpendicular to segment WL, and the reason for that is given. That's right. I'm going to use red to fill this in. Okay, so given. Okay. Now, from this statement, we have to state something else. And the reason is that perpendicular lines create right angles. So probably right here, we're going to mention something about some angle being a right angle. Now, I'm not sure exactly which angle we're talking about because I can see two angles here, right? HEW is a right angle, but so is HEL. So how do I know which one to say? Well, the next step says the measure of angle HEW is 90 degrees. So yeah, we'll probably say that angle HEW is a right angle, right? And we can say that because perpendicular lines create right angles. Okay? And then that makes sense here that angle HEW is a right angle. The next step that follows is that the measure of angle HEW is 90 degrees. Now, why do you think we can say that? Once we've said this thing is a right angle, how do we know it equals 90 degrees? What kind of maybe reason might that be? Yeah. Exactly. It's just the definition of what a right angle is. If you want to abbreviate, you can just put like def. Okay. All right, step 4. This is going to be an easy one because it's given to us. So what's the other given that we haven't mentioned? There you go. And then we have these two equations here that we've stated. Measure of angle HEW is equal to the measure of angle A, and the measure of angle HEW is 90 degrees, and we kind of put those two things together, don't we? This together with this becomes that. So what kind of property we may be using there? Substitution, I would even give you transitive, but I think substitution is probably the more correct one there. I think substitution is probably the more correct one here. So substitution. And voila, it's proved. Okay, substitution property. Okay? Not too shabby there. Okay? On the quiz on Tuesday, it'll all be statements over here, and then you'll have to give the reasons over here. Okay? So all the statements will be given to you, you'll be given the reasons. All right. Let's go to the next one here, and then this will be the last one we do. Okay, I'll give you guys your assignment. So, ray HB bisects angle CHU. CHU. Okay? And then we know the measure of angle 1 plus the measure of angle U, okay, equals 90 degrees. We want to then show that angle 2 and angle U are complementary. All right, it's kind of strange, but again, this is kind of a weird thing to prove, but it makes, I mean, it's got to be true, right? Because what do we know about angle 1 and angle 2? Since HB bisects angle CHU, what's going to be true about angle 1 and angle 2? They're going to be what? Equal, and so if angle 1's measure plus angle U's measure is 90 degrees, well then certainly angle 2 and angle U must also equal 90 degrees and therefore be complementary. So, pretty straightforward there, I hope. Okay? So, all right, let's see here. What's going to be our first statement here? Yeah, ray HB bisects, that's right, angle CHU. Now you might wonder, but Mr. Widmeyer, there's two givens there. There's two givens. How did I know how do I know this is the one that I put down here? Anyone have an idea?
The other one's down there, so you can see it.
That's right. Is that what you're going to say, Drew? Yeah, the other one is down here later in the proof. So what's the reason for that one going to be?
Yeah.
That's the other given, okay? So yeah, the other one's stated later. So that's why that's why I knew it had to be that first one. Okay. So, again, immediately after we say that ray HB bisects angle CHU, we're saying that the measure of angle 1 is equal to the measure of angle 2. What fact then? How are we connecting from this bisector down to here? What's the reason for that? That we created these two congruent angles here. What is that?
Definition of angle bisector.
Yeah, that's right, Maria. Definition of angle bisector. And again, I'm just going to abbreviate there. Definition of angle bisector. Okay, an angle bisector, by definition, creates those two congruent angles there. Okay. Okay, and then we're not given the statement for step 4, but we're given that there's a substitution that goes on here. So, yeah, Michael, what are we going to plug in?
M angle 2 for M angle 1.
Exactly right. Measure of angle 2 goes in and replaces the measure of angle 1. And then we go from the measure of angle 2 plus the measure of angle U is equal to 90 degrees. We go from that to then saying that angle 2 and angle U are complementary. And what do you think the reason for that is? Mary? You got it, Mary. Definition of complementary angles. Okie dokie. So that's it. So on the back, there's one more, and I want you guys to try that for homework. And then in addition to that, I have a little paper right here, okay? The homework then, in addition to that, I'm going to pass around this paper. You'll see here there are angles with letters, and I want you to figure out the missing angle measures. And it says no joking around, because I guess there's no actual joke on this. So, womp womp. It's just a serious case. Keegan, thanks for putting that back, appreciate that. So, if you guys want to return your tools,